Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. In a previous lecture, we talked about plotting things over time, seeing how trends unfold over time. So in this lecture, I want to talk about space, and how it is that we can plot things on maps. There are a couple of different ways to plot things on maps. One is you can just plot things by latitude and longitude, which turns out to be fairly straightforward in R. The other is that you can plot shapes and color them in to represent their relationship to one another. That's a little bit trickier because you have to connect the data to the shapes you're interested in. For example, the usual example is the big map you see every election night showing all 50 states colored in red or blue. Right? Well, the short version is that you need to find a file with all of those states in them, which is straightforward. You need to find a file with the vote share and figure out who won, and that's pretty straightforward. What's not entirely straightforward is connecting the two. So we will talk about that in a subsequent video. So what are the general principles for creating a map in R? They're pretty straightforward, and they're common to just about every map that you make. First is you need to load some sort of library in R that generates maps. Our world map is a good example. Maps is another one. Map data doesn't plot maps on its own, but it has data that the maps package can use to plot more high-resolution maps. So there are a few of them. The next thing you need to do is find the variable that interests you, the quantity that interests you, whether it's vote shares or whatever. Right? You got to go download your data set, the data set that interests you. The third part, the trickiest part in some cases, is connecting the observations on your variable to the locations on the map. That is, if California is meant to be blue in your election map, you need to get your data set of election results and your data set of map coordinates and connect blue in your election data set to California in the maps data set. That can be easy or difficult. For a straightforward geographic map where you're plotting things by virtue of using longitude and latitude to locate whatever it is you want to plot, it's actually pretty straightforward, because when R plots a map of the world or a map of a particular country, it uses latitude and longitude for its x and y coordinates. Now, the big advantage to that is that when you try to situate something on a map, all you need to do is plot it at xy coordinates that correspond to its latitude and longitude. So we'll see in this video how straightforward that can be. If you want to color in countries on a world map, you will need to find the ISO 3 codes for the country names. This is the most straightforward way, because country names can be all over the place. As we've seen when we've looked at data in Wikipedia, you can have People's Republic of China or China, People's Republic, so on and so forth. So the best way to do it, the most straightforward way to connect the region of the map to the quantity that you want to graph is by ISO 3 code. For U.S. states and U.S. counties, there's a Federal Information Processing Standard, or FIPS code, that you can use to connect the data to whatever, the state, the county, or whatever. So you need to ideally find data that come with FIPS codes. And then finally, you need to plot the data. Okay, so we're going to do today an example of plotting things just using latitude and longitude, because it's the most straightforward way to do it. And the best way, one of the easiest ways that we can show how to plot things on a world map is to plot earthquakes. So how do we draw a world map? First of all, well, we need a couple of libraries. We'll bring in our world map library, which exists for world maps. We'll bring in the maps library, which has both the world in it and the USA, and we'll bring in the Map Tools library, which allows us to import shapefiles. That's going to be important later on. The first thing you do, you type in map, quote, world, end quote, and that will draw a world map. And when you do that, what you'll see is that the map is fairly chunky, sort of low resolution. So the second thing to do is to bring in the map data library and type in map, quote, world high res, end quote. Now, because you've brought in the map data library, the maps library, which has the map command, now has available to it a set of shape files called world high res. And when you plot them, this is the map that you end up with. So it's fairly nice and scales to a considerably bigger size than this before it starts to look chunky. So we've got our world map. Now, what are we going to do to get earthquake data? Well, we talked in a previous lecture about APIs and about the fact that there is a usgs.gov API that contains data on earthquakes that have happened in the last 7 days. Excuse me. The API is online. It's constantly updated. Whenever there's a new earthquake, it goes onto the list. And we don't have to read it in any strange formats. It's online. It's already in CSV format. So it's pretty easy for us to access using R. Once we've downloaded the earthquakes data, we're going to plot the earthquakes by longitude and latitude. We're going to use the symbols command to do that, as you'll see, which helps us to locate objects on an existing plot. And then once we've done that, we're gonna look at what we like, what we don't like, and how we can go about tweaking the things that we don't like and make them more likable. All right, so we start off by going to earthquake.usgs.gov and taking a look at the earthquake API. And it looks very much like this. What we're going to do is read it into an object in memory called quakes. Okay. So we use this command up at the top of the screen. It tells us create a new object in memory called quakes, and you're going to fill it with the contents of whatever you find at http://earthquake.usgs.gov, etc., etc., etc. Right? And we also, because we're using the read CSV command, we're telling it what you find there is going to be in CSV format. So we do this. We can take a quick look at quakes, which I didn't reproduce the output here, but if you type in summary quakes, it'll give you a brief rundown of the values of all the different variables that you saw back here. You've got date, time, latitude, longitude, the depth of the earthquake, the magnitude, so on and so forth. We mostly care about latitude, longitude, and magnitude. Okay. So now we're going to use the symbols command, and we're going to tell it, all right, at longitude X and latitude Y, what I want you to do is put a circle. And we'll set the background to be red. That's the center of the circle. And the size of the circle is going to be 1. Now, sizing is a little bit curious with the symbols command, and I'll try to explain it in a way that makes sense. I'm not sure it was written in a way that makes all that much sense. So the circles command, what I've done is create a vector of ones that is as long as the data set. It has as many observations as the data set. That is as many observations as there are earthquakes, right, in the last week. How do you know how many earthquakes there are in the last week? Well, we get a longitude reading for every one of them. So all I do is tell it, tell me how long the quakes $longitude vector is, and that's the number of earthquakes we've had. So now I want to, for circles, I want you to create a vector of ones that is as long as the number of earthquakes that we've had. Now those ones are going to tell us what the diameter of the dots are on the map. So, and they control the diameter of the dots relative to each other. The next subcommand, inches, scales all of the dots relative to the map. Right? So if I type in inches equals 0.02, that means they're relatively small dots. If I make it inches equals 0.2 or 0.3 or 0.4, that means they're all bigger. Right? So you have two ways to control the size of the dots in this map. One is with the circles command, which controls their size relative to each other, and then the other is the inches command, which makes them all bigger or smaller, or inches subcommand rather. And finally, I put add equals true, which means instead of erasing this map and plotting a new one, I want you to add it to the existing map. Okay? Now, this is a fairly straightforward map of where all the earthquakes are. The problem is that it doesn't really differentiate. Some of these are tiny, tiny, tiny earthquakes, whereas others are pretty substantial. So we want to bring magnitude into this and make the sizes of the dots bigger or smaller depending on the magnitude of the earthquake. Now, to understand that, you have to understand how the Richter scale works. All right, it's a logarithmic scale, and that's why when people talk about a magnitude 5 earthquake versus a magnitude 6 versus a magnitude 7 or 8, these get very abruptly big very quickly, right? And that's because the magnitude of a magnitude 7 earthquake is 10 times that of a magnitude 6, right? And a magnitude 8 is 10 times that of a magnitude 7. So these get to be really, really big earthquakes very quickly, right? The smaller ones are actually, there are obviously considerably smaller differences among them. So, how do we scale our dots in order to reflect this? Well, if you want to do the opposite of a logarithmic function, you take something, you take e and you raise that number to, you raise e to whatever power your number is, 7, 8, 6, so on and so forth, right? So what we're going to do is go back to the World High Res map. We're going to gray it out a little bit so that we can see the earthquakes a little bit better. And we're going to get rid of the margins because we want to have a bigger, clearer map. Now, with the symbols command, what I'm going to do is I'm going to plot the symbols at x equals longitude, y equals latitude. Now I'm going to add a command fg equals na. That means take away the foreground of these observations. Well, what's the foreground? The foreground is just the ring around the red dot that you saw in the previous graph. And for background, what I'm going to do is I'm going to give it an RGB code that says I want red and I want it to be mostly transparent. So FF is red, 0000 tells you no green, no blue, and 22 says make this somewhat transparent. Okay? So the nice thing about transparency is you can actually see multiple earthquakes in one place. So for example, if you take a look, it looks like it's in northeastern Afghanistan. There are two circles superimposed on one another, and those look like they're probably, an earthquake and an aftershock. There are a couple on the coast of Mexico that look either concentric or very nearly concentric, and those may well be an earthquake and an aftershock. So this gives us a better sense. As for the size of the circles, what we're going to do is take the magnitude, take 2.7, which is close enough to E for our purposes, and raise it to the power of the magnitude of the earthquake. And we'll scale the inches scale so that the magnitudes of the earthquakes roughly correspond to what intuition would suggest. Okay, now they don't correspond to, this is how far away you can actually feel the thing. That's a much more complicated calculation, and it depends on a lot more than just the magnitude of the earthquake. But but this does give us a good sense of where the earthquakes are, how severe they are, how many there are, and how big they are relative to one another. And again, we're going to add this to the plot. So this is a considerably better visualization, right? It shows us a lot more about the earthquakes, but there's still a lot of detail that we don't really care that much about. In particular, I'm not entirely I mean, in some cases we might want to know exactly which country an earthquake is in, but for the most part, the lines in the map are detail that we don't necessarily need. So for the next step, what I want to try to do is color in the continents. Color in get rid of the country lines and color them all one sort of uniform color to make for a clearer, more straightforward visualization. Now we can do that with the fill equals true command. Now all the rest of this is the same. The only thing that we've added here in the first line is fill equals true. That means fill in all of the country shapes in the map. And LTY equals 0 means don't draw any lines between them. So this is, again, better. And if you take a look at it, you're less distracted by the lines between the states, and you're more focused on where the earthquakes are relative to the continents. The problem is, if you take a look at Africa in particular, you can see that the lines between the countries are neither entirely gone nor entirely there. When you draw the individual shapes and fill them in, they don't quite fit together perfectly sometimes. So what we need to do if we really want to do this is abandon the World High Res map, which isn't really suitable for this purpose, and download a map that contains the shapes of the continents. So this will give us a good example, a good excuse to go looking around for shapefiles and using them in plots. So we're going to search for continent shapefiles using Google. And as I mentioned before, a shapefile is it's a file with vector commands in it that tell a piece of GIS software how to draw a particular shape on a map. And I found continent shapefiles at arcgis.com. Here's the URL. What you do is you download the shapefile folder. You look for the file that ends in .shp. That's going to be your shapefile. And then once you've loaded in, now remember I said we're going to use the map tools library. Once you've loaded in the map tools library, you have a command called read shape spatial. And we're going to use that command to read in the continent shapes. So here's how we do it. We create a new object in memory called continents. We use read shape spatial to read in the continent shapefile that I downloaded from the previous example. And now, instead of plotting the world map, we plot the object continents. And we tell R to give it the color of gray 90, which is gray, not terribly heavy. You can change sort of gray 80, gray 70, and darken it a little bit, right? But we're using gray 90, which is fairly light. LTY equals 0, meaning no lines around the continents at all. And we're going to use some symbols to plot the earthquakes and their magnitudes, and nothing in the symbols call has changed. So what we end up with here is a nice graphic of the continents of the world without any political divisions, and the locations of all of the earthquakes on that map of the continents. So that is our earthquake map. And next time I'll talk about how we can go about connecting data to shapes in a map and creating choropleth maps.